So our learning goal is the same today. And it is, I can graph more than one set of values on a number line. So again, we're going to not only do the graphing though, we're also going to, I've added to it that we're going to show a compound inequality statement for each of these also. So let's start with, I think somebody who wrote this material likes Las Vegas. Las Vegas is in the word island again today. When it gets hot in Las Vegas, children are encouraged to play outside in the morning and in the evening when the temperatures are cooler. Usually children play outside in the morning when the temperature is 81 degrees Fahrenheit or hotter until it is 84 degrees. They also play outside in the evening when it is 86 degrees to 90 degrees. So we have how many situations going on here? There's two things, right? That's going to make it into a compound inequality. And so we're going to, let's underline that they're going to be playing outside in the morning when the temperature is 81 degrees or hotter until it is 84 degrees. So temperature is 81 degrees Fahrenheit or hotter until it is 84 degrees. Okay, so let's just go and graph that right away. So we're going to put a circle at 81. Are they going to, should we shade that one in? Are they going to be outside when it's 81 degrees? Yep. So it says, and then or hotter, but let's worry about that after we do the 84 degrees. Are they going to be outside when it's 84 degrees? They are to begin with, and then they're going to probably go in, right? If it gets higher than that, then they would go in. So we would shade that one in also. And anything in between there should represent being hotter than 81, but yet they go in when it's 84 degrees. Okay, they also play outside in the evening when it is 86 degrees to 90 degrees. So we're going to go to 86 and put a circle there. Would they be outside when it's 86 degrees? Okay, this is the one, this is always the one that is so tricky when they just use the word to, T-O. 86 to 90 degrees. You know, we're going to include it. We're going to say that it says they play outside when it's 86 degrees to 90 degrees. So it sounds to me like they would be outside if it's 86, 87, 88, 89, or 90. Okay, so we're going to shade 86 in, and we're going to shade 90 in, and then we're going to shade all those temperatures in between, which of course there really are more than just 87, 88, and 89. Those are just the whole number temperatures. There's a whole bunch of parts like 87.5 degrees. That would count also, right? Okay, so now we're going to write the compound inequality statement for that. This is going to be an OR one because we have two different regions shaded. So let's write the inequality for this one first. Okay, it says let T, so T is our variable, so circle that. T is going to be our variable involved in our compound inequality. So we look at this one and we see we have endpoints 81 and 84. So we start with 81. Because 81 is shaded in, we include the equal to bar, is less than or equal to. What's going in the middle? T. Make sure it looks like a T, not a plus sign. Somehow make it look like a T. And then we're going to start with, or the 84 I mean, is at this end, so and it's shaded, so now we're going to say is less than or equal to 84. So our compound and inequality is showing those two endpoints with the shading in between. Now we're going to include the word or. We're saying, oh, but that's not the only thing shaded on this graph. Or they also can play outside when it is 86 degrees. So 86 is less than or equal to T is less than or equal to 90. So all of that shows when the children in Las Vegas usually play outside. Questions, anybody? Okay, I want you to try to graph the next one on your own. Read it and graph it. Just graph it, okay? But the underlining trick helps. Okay, can somebody help me graph the yellow highlighted part on mine? Somebody help me graph that part? Tyler?
5 is the circle shaded,
You want me to shade it in? Okay.
and then put a circle around the 8.
But don't shade that one, okay?
And then
Shade in between, okay. Can somebody help me graph the blue highlighted part? Kaden?
Shade the circle 13 shaded in.
So shade it in, you said?
Yeah.
Okay.
Circle 18, leave it open.
Leave it open, okay.
And then shade in between.
Shade in between, okay. Okay, anybody want to challenge either of those gentlemen because yours is different and you didn't want to say, I think it should be this way? Kaden?
I kind of thought for the first one, since it says we're older than 5 years old, it should be open. Because where it's shaded in means it's equal to.
Okay, so what do you think, class? Aiden's challenging the first one. He says, I think the circle at 5 should be open. And he says, because it says older than 5 years old, so 5 should not be included. Anybody want to agree with him on that? Should we change that? What do you think? Tyler, do you think so? Okay, Tyler's willing. Good. So with the rest of you, some of the rest of you think we should do that, so let's get that one changed up. We're gonna leave that one open because you can't really be 5. It says older than 5 and younger than 8. So we're good on that one now? Anybody want to challenge the other one? Any part of the other one? No? Okay, then let's write our compound inequalities. So what's our first part of our inequality going to be? The first part not of our compound inequality. Harley? I want more than that. I want the whole statement before the or. Okay, A is what we're supposed to use. And what? Okay. We agree, class? 5 is less than A and A is less than 8. Okay. And then we put the word or because we got more on the graph. And what would our other part be? What would the other part be? Cheyenne?
13 is less than or equal to A, less than 18.
Okay. Did I write it the way you meant it? Everybody agree with that one? Okay, good. So did you do some underlining in the problem or some circling or something to help you out? Okay, let's go to the back side. I think we have a couple more we're going to practice before you start on your homework. Okay, well, what's this board doing? That's a good question. Okay, you read the next problem to yourself. Okay, any suggestions for what should be underlined or circled or drawn our attention to in the problem itself? That's one of the things maybe you did, Tyler.
I have in mind at least 104 degrees Fahrenheit and no hotter than 110 degrees.
Okay, so that part right there. Okay. Kagan?
At least 114 degrees and no hotter than 18 degrees Fahrenheit.
Okay, so it looks like there's two parts again, doesn't it? Okay, so let's graph that. So at 104, we're gonna do what?
Shaded.
Shade it in? Because at least means it's included or it isn't?
It is.
At least means it is included. And then it says, and no hotter than 110. What are we gonna do at 110? Keep it open? No hotter than 110. Can it be 110?
Yes.
It just can't be
Hotter.
hotter than it, so we want to shade it in, don't we? So at least 104, but no hotter than 110. So that's what that should look like. Okay, how about the other part? 114 degrees. Should we shade it in? Can it be 114? At least 114. But no hotter than 118. Should we shade 118 in? Yes, okay. And so at least 114, but no hotter than, so it stops right there at 118. And our variable this time is what? V. Okay, let's write it out. 104 has to be less than or equal to V. It's the smallest one, and V can also be, or has to be, less than or equal to 110. What are we going to write next? Or, there's another part of the graph. So now we're going to describe the other part of the graph. Yesterday, or the day before, whichever day it was, we had a compound inequality and a simple inequality. Today we have two compounds put together. So what's this one going to read? Help me out, class. 114 is less than or equal to V, and V is less than or equal to 118. There we go. Okay. Whoops, I want to totally hide that. Okay, you're on your own for number 4. You can look up at mine when you're done completing yours totally. Now, I think some people are start paying attention here because yours right here does not match yours. volunteer to do the graph? Come on up, Cheyenne. Bring your paper with you or put some notes. Just the graph for us, please. Check to see if you thought the important things in there were what I did by my highlighting. Okay, thank you. Anything that touches the board writes, isn't that crazy? Okay, do I have a volunteer to come write the compound inequality statement for this? Take them on, Danny. Was your hand up after Hannah? Or were you stretching? Oh. You're deceiving me, I thought your hand was up first. Okay. Finish yours up before you look at hers. Sure you're done. You need the eraser? Okay, I'm gonna give you a small eraser so it doesn't erase more than you want it to. Okay, you done erasing? Okay, there you go. Okay, let me remind everybody one more time that I and you have to be able to clearly tell when your circles are open and when they're shaded in. Okay? If I have to guess or I have to look and study it, I'm like, no, this is not going to work for me. I'm not going to try and pretend I know what you meant, okay? So, anybody have any challenges for what's up here? Anything we want to challenge and say, I think it should be this way instead, maybe? Okay, one of the things, I'm going to give them the benefit of the doubt because they were at the board and it's hard at the whiteboard. This would be one of those things that sometimes it's very hard for me to tell when there's any part of the circle open. I can't really tell, were you meaning to shade it in or were you meaning to leave it open, okay? So make sure, everybody look at their papers right now. Yes, these all should be shaded in, all four of them, and make sure that that's what they look like. This is the easy part of the math class, shading in the circles. Make sure I can tell, and you can tell. And when they're supposed to be open, make sure I can tell. If you make them too small when they're open, and they kind of blend into the line, it's hard to tell. So you have to make sure, take the time to make sure that you and I can tell what anybody who looks at your paper can tell what kind of endpoints you have. Are those endpoints shaded in or are they not? Okay? Anybody have questions? Good job, those of you who finished up the problem for me. It is correct, right, class? Are we agreeing with it? Yeah? Okay, then let's get out some loose leaves to get ready for homework.